Hi and welcome to this section. In this section, we will be learning about what Docker is and how Docker is important in the field of software development. Let us understand the concept of Docker with a requirement here, right? So let's assume that we have a requirement to set up an end-to-end application stack using various different technologies like Java for our web server database, such as MySQL, and a messaging system like Redis, and orchestration with Azure DevOps. So considering this requirement, let's assume that we have an issue developing this application using all these different components. Firstly, let's talk about the compatibility issue. The compatibility with the underlying OS was an issue. So we had to ensure that all these different services or components were compatible with the version of OS which we were planning to use. There have been times like when certain versions of these services were not compatible with the OS, and we have to go back and look for a different version of OS that was compatible, and all these different services were compatible with that particular OS. And then secondly, we had to check the compatibility between the services and the libraries and dependencies on that versions, OS versions. So we have had an issue where one services require one version of the dependent libraries, whereas the other services require the other version of the dependent libraries. Now let's assume we have built an application overcoming all these compatibility issue as the version dependencies or the library or other dependencies. We have built the applications. Now over time there is a requirement again to change the complete architecture of our application, and we have to upgrade to the newer versions. For example, the Java needs to be upgraded to the newer versions, or also there might be a request to change the database offering, which in case currently we are using MySQL. And every time something changes, we had to again go back through the same process and checking the compatibility between the various components and also the underlying infrastructure and operating systems. Isn't it a tedious task here? This compatibility issue like was a tedious task to maintain, and it was a very time consuming process for any kind of software development or setup, or also development and shipment, let's say. So every time we had a new developer on board also, it was very difficult for him to set up his environment to work. The new developer had to follow a large set of instruction, and he has to run hundreds of commands to set his environment. So we also have to make sure using the right operating system and the right versions of each of these components. So all of this made our life developing and building and shipping the application very difficult. Thus, considering all these drawbacks, we needed something that could help us with all this compatibility issue, and something that would allow us to modify or change the components without affecting the other components, right? And even modify the underlying operating system as required. And this is where Docker comes into picture, and this is what Docker's resolving also all this compatibility between other libraries and dependencies on a OS level, sorry. Using Docker, we can able to run each component in a separate container with its own dependencies and its own libraries, all on the same VM and the same operating system within a separate environment or containers. We just had to build the Docker configuration file once, and all our developers could now get started with a simple Docker run command irrespective of what underlying OS they are using. So all they needed is just to install the Docker in their machines. That's the only requirement here in this case. But in the previous case, We require the right versions of OS to be installed, the right versions of the component services needs to be installed. So this compatibility issue and all these dependencies have been resolved by Docker already. Now you can just figure out the difference between the containerized application or the Docker application and the traditional application which we usually host it on our virtual machines, right? Hope you have already got a high level overview about what Docker is doing here and why is it so important in the field of software development. Hmm. Now, since I spoke about containerization here, let us understand what containers are. Containers are nothing but these are the complete isolated environments, as they can have their own processes or services running, their own network interfaces, their own mounts, just like the virtual machines. Only difference is they would be running on the same OS kernel and the same operating system here, right? Docker utilizes the LXC containers here. The main purpose of Docker is to package our application, containerize it, and then make us easy to ship the application. And thus we could run this application anywhere, any times, as many times we want. Right. Now you can just figure it out again, the difference between the containerized application and the virtual machines here. In case of Docker, we have the underlying hardware infrastructure and then OS installed on it and then Docker installed on it. Docker then manages these containers that run with different libraries and dependencies along with their virtual machines. Whereas in virtual machines, we have the hypervisors like EXSI on the hardware and then the virtual machine installed on top of it. As you can see, each virtual machine has its own OS inside it. Then the dependencies and the applications that are overhead causes the higher utilization of memory here. The virtual machine also consume higher space as compared to the containerized application in our Docker, whereas it would be in terms of gigabytes, and in our Docker containers this would be very lightweighted and usually it would be in megabytes in size. And considering all these aspects, Docker allows the container to boot up faster, usually in terms of seconds, whereas VMs, we know it usually takes minutes to boot up as it needs to boot up the entire operating system. And it is also important to note that Docker has less isolation as more resources are shared between the containers like the kernel, whereas VMs has complete isolation with each other since VMs don't rely on the underlying operating system or kernel here. You can run different types of application built in different OS here, such as Linux based or Windows based on the same hypervisors. So these are some differences between the two. Now let's understand the difference between images and container here. An image is a package, let's say. We can consider it as package just like our VM templates here. So these are also nothing but the templates just like VMs. It is used to create one or more containers out of it. Containers would be running based on the image here. And containers are running instance of our images. So this would be isolated and have their own environments and set of processes as we have seen it before here. You could create your own image and push it to Docker Hub repositories. There are multiple other providers. We have Docker Hub repositories. We have Azure Container Registries in our Azure. And it would usually make it available public or also it can be maintained in a private manner also. But let's assume we are publishing our images to a Docker Hub registry which is available for public. So we'd be looking forward and checking how to develop an image using a Docker file and how to publish it to a Docker Hub registry, as well as let's see how to publish it to Azure Container Registry in our further sections. But for now, just to give an insights that we can also able to develop an images which would be responsible for running our containers. So this would be done using our Docker file. We will be looking it in further sections. And to continue with the current explanation here, just to compare our traditional developers and the container applications. Traditionally, developers develop the application, then they hand it over to the ops team. The ops team is now responsible to publish it into the production environment. They do that by providing a set of instruction here. The developers provide the set of instruction to the ops team about how the host must be set up. What are all the prerequisites application needs to be installed on the host before before running our application containers, let's say. Not containers, running our applications. And all these configuration, so all these would be provided by developers to our ops team. Since the ops teams have not developed this application, they would be struggling to host these applications, right? In traditionally, but whereas in the Docker way of containerizing our application, it's very simple. Here in this case, the ops team work with developer to resolve this issue again. With Docker developers and operation teams, transform all the Docker file with both their requirements, how it needs to be hosted. The Docker file is then used to create an image here. Simply just they would be providing a application image, just like our VM templates. And ops team does just run one command, which would be docker run command and run a container out of an image. Just he should make sure that there should be a Docker installed on the host machine so that he could run the Docker commands and containerize the application using an image. So the ops team can now simply use this image to deploy the application since the image was working fine in the developer machine where the developer has built it. So it would be working. It is also guaranteed that it would work in any of the other machines and other platforms, let's say. So this was an example like how the Docker contributes to the DevOps culture here. So hope you are able to understand the concept of Docker and how it is helping in development as well as publishing it onto internet or making it available to public. So if you have liked this video, please give it a thumbs up and follow us, subscribe us for more such content. And by the way, we'll be uploading more such videos in the coming days. Just check out our playlist to view all those. Thank you all.